Hello everyone, welcome to another training video. This is Python Basics Part 2. It's a continuation of Python Basics 1. This video covers multiple assignments, variable assignments. It covers data types, including the 4 core data types in Python, which is numeric, float, Boolean, and complex numbers. By the way, I've never used complex numbers in my projects, but I at least want you to know how to create a complex number and how to figure out its type, where it's located, its bytes and sizes and stuff like that, in case you need that information. Just like all the other ones, we'll go ahead. I would suggest that you program with me, because at the end of these you'll have everything that you need about whatever that video was focused on. Alright, let's go ahead and get started. Alright, today we're going to start with multiple assignments. Let's call it multiple TPLN assignments. Okay, alright, so multiple assignment is, in the earlier videos we assigned variables like, A is equal to, let's go with the back end. So say X is equal to 10. We'll assign that, to shift enter. We got a variable over here is 10. Say Y is equal to 25, and then Z is equal to 13. Just making up numbers. Alright, so right now we have to assign these single assignments where we assign the variables created, stored. 10 is stored in that memory location. It's assigned to X, so we can actually have an access to it, and then we did that for Y and Z. Now you don't have to do this one line at a time. You can do as many assignments as you want within one line of different types of data types. So say we wanted 4 more variables. We wanted A, B, C, and D, and we wanted A, B, and C to be string data types and D to be a float data type, and we want to assign all of those data types in one pass. So what we can do, we can say A, comma, B, comma, C, comma, D, and that is the variables we want to assign. And in that same order, we need to assign the variables, and they're going to be assigned in the same order that they are in that you actually instantiated. So for instance, when I say equal, whatever I put first is going to be assigned to A, because A is in the first position of the variable list. So we said 3 strings. So I'll say my first name Michael. Just use names John and Kate is for A, B, and C, and then we'll have 34.57 in D. And when I hit shift enter, as you can see on the right side, remember I don't know if you're jumping into this video, I am using the Spider ID. Remember these tutorials are linear, so if you haven't went through the videos before, that's how you can learn how to use this IDE. And I'm also using the RStudios layout. So RStudios layout in Spider, just because I'm very familiar with the R language as well. Once you hit shift enter on this, as it assigned in memory, you see A, B, and C was assigned to those names that we talked about, and then the float was assigned 34.57. Okay, so that is what multiple assignments are. Now you could also have where all the variables are assigned to some single number at one location. So for instance, say next line, say I wanted A, B, and C and D to be assigned to the same number. You remember we talked about in the past how I showed you how to look up the memory like where is this value is stored. And we noticed that without a special copy, they'll all have they'll be pointing to the same value. So say we want to do that, so we could say A is equal. Make sure I'm doing this right. Yep, A is equal to B, which is equal to C, which is equal to D, which is equal to let's pick a number of 100. If I do this, you'll notice that all 4 variables are now assigned to 100, and they are all assigned to the memory location where 100 is actually located. So if I were to change A I think based on that, all of them would change. If I said A is equal to 20 now and shift enter, now A is not assigned, so I'm incorrect. A is not assigned. A is now assigned to 20, which is where 20 is stored in memory. But B, C, and D are still assigned to memory location 100. So you can always take it off. So I was wrong for a little bit. I was thinking that because they're all assigned to the same memory location, when I reassign A, I'm actually asking it to point somewhere else, while the other three are still pointing to the other memory location. So that's a way to assign multiple values to the same location, and maybe you have it where maybe later down in your program some of those variables can be assigned to other locations given the nature of the assignment that you're trying to solve, or the problem you actually are trying to solve. Okay, next we're going to talk about the data types. We're going to look at the size of the data types, and then to a way like in code, because you're not always going to have a GUI to see what the types are. If it's true, like you might want to know if a variable is of a certain type. There's a couple built-in functions and stuff that are laid out in Python to allow you to do that. All right, so one important package we're going to import is the system package. It's a good package to look at the size in bytes of objects, so you can get a feel of their sizes. So I'm going to import the systems package. So you type in import, and then SIS is the name of the package. This package should have installed. I think it's a base package of Python. You don't have to. I think it installs with all Python packages. So when you shift enter, now we have access to be able to call those functions. So one of the things we're going to start with looking at the int type. As you know, the int type is what we already have installed. If you look at our variable explorer, we've created A, B, C, D, E, A, B, C, and D, and X, Y, Z. They're all int type. If you wanted to know the type, say, like I said, you're not always have Spider, which is a really cool GUI, but in a lot of production situations, you might not have a GUI to see the type of an object. To be able to get the type of an object, you can do type. It's a keyword, and then the name of the variable. So in this case, I'm just going to pick X. And if I do shift enter, it returns back what the type is. So this value is type int. And if you see over here in the GUI, for X, it's type int. So the type command pretty much is telling you what it's showing you here in the GUI, what type of type it is. All right, next step would be you might want to know the size of the object. So that's what the system. So how many bytes does this object take up? So for X, let's see, I think it's syst, which is the name of the import, dot, and I think it's get size. Yep, get size of the object. I will type in X, and then when I shift enter this thing takes 28 bytes. So the number 10 is taking up 28 bytes. So let's do a little play. I want to see how to make it big. So right now X is 10, right? And it's taking 28 bytes. What if X was, you know, since this is an int, it's still not going to be a lot, but say if X was X, big old number, right? If we look at the size, you see now it takes 32 bytes to hold that number. So the larger the numbers, the more bytes it take. Bytes are grabbed from RAM, random access memory. Therefore, the heavier the objects, the more RAM it is to store it and stuff like that. You won't have this issue with these assignments, but that's something to know about, that some data types are just heavier than others. For instance, let's create the same thing, but I'm gonna store this as a float. All right, so we're just gonna put a .0 on it. So right now I'm gonna copy this down here so you will know in your code that it won't be like you just keep changing everything. All right, so down here I want to make X, I'm not gonna mess with X, we'll mess with Y. So Y, I want it to be the same number, except I want it to think it's a float. And the easiest way is just to put 0.0 because that's gonna, that dot with the 0 is gonna let it know it needs to be a float type. And as you see here, it's a float now, which means it has a lot more precision, but it's the exact same number. It just is a float. And if we look at Y space, it's actually, it's interesting. It's actually a little less bytes. of the same size, even though it's the same number. I don't know. I can't honestly say I'm going to go into the software science aspect of it, but in this case, the float is smaller in size of bytes than it is as the int was a little bit bigger. So there's things you might want to do. You might want to be able to get the size of the bytes, to get to the type it is, and then there's another function that's very common to know if it's of a class. Like if it, remember I told you everything is kind of class oriented. So is the number that you're seeing, or the variable you have, is it a int? If you couldn't see it, it's part of your code and you want to know if it's true or not, there's a special function called isInstance. The isInstance function, you pass in what you want it to be and then tell it the type of the instance, and then it will return back to you if the instance is what you think it is. So for instance, if I say isInstance, isInstance, and then x, right? And then it wants to know, like it's telling you what it is, and was it a class or a tuple. So you got to say what class or tuple. So in my mind, I want to know, is x a float? That's the class float. When I hit enter, it's going to say false because x is not a float. X is an integer. So if I go down here and do the exact same piece of code again, I'm going to put it was false here. False. And then so here, if I say x, I want to know if it's of type of class int. I do control enter. As you can see that now it's saying it's actually a enter. So if we had a whole set of numbers, right? Say we wanted to as you see, as we keep doing this over and over, we're kind of doing the exact same kind of code over and over. And I'm going to have a video. I know there's a video about functions, but I want us to create a simple function right now that we can use to just look at the different types, so we don't actually have to write this piece of code over and over as I go through the different types. So this will be the first time we talk about creating a function. Again, I'll go more in depth in functions in the functions tutorial, but I would like us to create this small function so we can actually play around with looking at different types of different data types. So we're going to call this function create a function as a keyword called def, so def, and then you have to name whatever you want the function name to be. Today I want it to be called data type checker, because that's exactly what it does. Now in this case, I would normally have a constructor, but you don't always have to have an actual init constructor to do it. Might not make sense to some. You can just open a variable space here to pass in the value. So I'm gonna call this value, and what this means is that this is a parameter for my function, or an argument for my function, my bad, and that once the function is built, we can pass in a parameter for my function, my bad. It's a parameter that once the object is built, we can pass in arguments outside of the function, and it can do a processing, a crunching of data. So look at a function as kind of like a recipe. It's a recipe of code in which you pass in the things it need, it goes through and crunch it out, and then it brings the things back. So what we're going to pass in is a number or a string or whatever, right? You'll need colon, because Python is space sensitive. So the colon lets it know that that's the end of the function name, and many object that we asked for it. So the tab space and enter mean that anything in this piece of code that we're writing now is going to be tied to that actual function. So everything in this function will be within this block of code, within this this tabbed block of code. And I actually, when I first started programming in Python, I wasn't a big fan of this because in other languages the space doesn't really matter. But the more I program in Python, I really appreciate Python's kind of way of trying to force uniformity and code, like we're making code easily readable. So I actually like this structure now over the years. All right, so what we're trying to do here, right? So one of the things I want to do in the function first, I want it to print the value, because in a function, you know how we were seeing these out statements. These out statements doesn't happen if it's in a function. you don't have to need a print statement. But if you're going to print when a function is doing something, in Spider, I can't say all IDEs, you have to actually utilize the print function. So I want to print whatever value is. That's the value that we pass. Next, I want to print out the type of the value. Type value, so we can look at its type. Then I want to print out, let's see, I want to get the size of the value. So we're going to print out the system.get size, get size of, and then value. And then what else should I do? Print out the size. We'll print out some statements for letting us know if it's a float, a integer, a complex, or a boolean. So let's print, let me see, I'm going to print the statement is the value a integer. I do it as a question, and then I say comma, and then this is where I actually do that instance function, instance of value that comes in. If this doesn't make complete sense right now, when I get done, I'll talk through what I've changed. I want to make sure you understand what I did. So this is an int, right? So we said to use the is instance function. We can use it to give us a true or false, a boolean result, if that is of that class or not of that class. So in this one, it needs to be int. All right, so what I'm going to do to speed this up, I'm just going to copy this 3 more times and then get it to check for the other 3. Okay, so I need to change the name first. Is this a float? And then in here we'll put float. Is it a boolean? And in this checker we'll put bool. And then is it a complex? And we'll put complex here. Complex. Yep. Take that off. Yep, just need it to be like that. Alright, so missing the parentheses. I accidentally deleted the parentheses that goes to the end. So you see how when I click here that it's showing I have parentheses, but there's an outer parentheses that I don't have. So Spider tries to help you clear up those types of issues. I kind of talked about this. And then last time the little error thing tries to help you out as well. So if I grab the entire function and hit Shift Enter, that actually created a function now that I can actually call. Like the computer in memory have stored this function, and it can actually call this function to do stuff with it. So for instance, earlier we did this stuff, right? So I'm just going to pass in x. X is going to represent value in this function. So we're going to pass in x into this function, and then it's going to do all these other things. So we call the function. When we say data type, you'll see now that the IntelliSense of Spider can sense that this function exists now, because it's part of, it's searchable. It's part it's now loaded into the possible functions for your session of Python, because you'll have to do this every time you create a new session. So if I click on that, it's expecting a value. I'm gonna put x in there, and when I hit Shift Enter, as you see, it tells you that this is the number. So value came in, it printed out the number. That's what this is. Then it gave me the type. It told me that it's of class int, and it takes up 32 bits. And then these questions are just kind of showing you how to true false. So it makes sense, right? Is the value an integer? True. Float, boolean, and complex is false. So the function is working correctly. So what if we have let's create a couple of, now with this function, that saves us from having to do any more code writing, honestly, for this video, because if I'm not mistaken, these are the core things I wanted to test. So let's make sure you've seen each type. So we made a float. Now we've talked about an int this whole time. We're gonna pass in y, data type checker Y, and then shift enter. It's going to say, because of that 0 now, it knows that now it's of class float, and it's 24 bits, and then it's false, true, false, false. Again, this might be more important for, I just want you to be aware of how to do this. I know it's more on the data science, I would call it computer science, software engineering side of things. They're more interested in bytes, because today's computers are just got so much memory and RAM now. But back in the day when I was coding, it was a big deal to truly understand how big the objects were that you were creating, because in general a class is heavier than like a structure, so these things are important. If we want to test the other types, we got to create them. So let's create a bool. So a bool is just a true or false. A bool is going to be two options for most cases. Either going to be true or false. In some cases they can be null. It's all about the language, but in most cases it's true and false. So we're going to make a variable that's true. Let's say q is equal to true. So now if I do shift enter, q is a bool. So when I pass it through my function data checker q, shift enter, you'll see now it returns that the value is true, which it is, and it's a special keyword because it's orange. So I mean it has to have some special meaning to Python. It's 28 bytes, so this is almost, is it heavier? It's almost as heavy as an int. Now a byte is really small. Like let's 28, 32. I don't want you thinking the bytes are big. Bytes are small by nature. And then it's not an integer. It's not the interesting. This is new information to me. I didn't realize it. Bools, you notice that it says it's an integer and it's a bool. The reason why all bools are integers because a bool only can be two numbers. A bool either can be true or a bool can be false. I'm trying to figure out how can I show that. I think when you type in bool, the class, if you pass in a 1 into it, shift enter, you'll see it's true, because a 1 for bool, the data q is true, so it's going to be 1. If I were to pass in q through here, I'm just going to remove q and hit enter, it's going to say true too, because a bool only takes two numbers. So if it was false, the number that gets passed in would be 0, and then I would show false. I don't even know what it does when you do numbers that are not 1 or 2. Okay, 2 shows true. I don't know what that means in sense, but I do know 1 and 0 are the two main numbers for Boolean. So when you use false, it's the same as you saying if this is 0, or if you use true, it's the same as you saying this is 1. So it's definitely represents of the int class, and then it's of the bool class, which represents it. So what you're seeing why it's true, I think in the bool function, this is how, when you use it, this is how it's actually used. So the bool takes a int as an argument and it returns back true or false, either 0 or 1. So the bool class must inherit from the int class. Therefore, that's how it's both int and both bool. That's my guess. I haven't really done any research on trying to figure out why, but I do know the bool class has an argument that takes in 1s and 0s, and it seems like it taking numbers higher than that, but I know 0 is always going to return false and 1 is going to return true. All right, the next thing I want to look at is a complex. So a complex number is that, I and j. So if you had a number like d is equal to 45 plus 2j, and you do shift enter, as you see it says it's a complex number. And if we do our data checker of d, it'll tell you here it's that's the number, it's class complex, it's 32 bytes, and it falls in the complex class. So again, I've never used it. I remember doing complex numbers in algebra when I was going through a college algebra many moons ago, but I never used this in my day-to-day work. I think it's used more heavily in the mathematics fields than it is in the engineering fields. Okay, so I think I have covered everything you need to know about, in general, the basics of Python. Um, so I think the next video that will be covered will be the strings, like all about strings. So we'll be talking about strings in the next video, and I will see you there. Take care and enjoy the programming.